Hello and welcome to the C++ Insights YouTube channel. I'm Andreas. I work as a C++ trainer offering classes worldwide, on-site or remote. This is my YouTube channel where I use my tool C++ Insights to teach you various topics related to C++. Welcome back to the channel. Today we are going to talk about how you can write robust code that just works, being free of any undefined behavior. I have a specific example today. So I have this class widget, and widget here contains a data field width. It comes with a default constructor and with a member function get that returns the width. I also have a function check here that declares an object of widget and returns widgets get. And in main here I'm calling check and using it. So it's for sure not the most real world code in what it's doing, but it's the real world thing that the default constructor does here. So especially from code coming from C++ 98, we often had default constructors written like that because we had no other way to express it. We didn't have equals default at the time. And now if not a specific case, we have a built-in data type. And built-in types have the, I would say, problem, or say feature that they go uninitialized. So there is no default constructor running for them. I'm sure you know that. My code here looks pretty fine, and it's just an accident. I would say that it really returns 0 if I change the compiler, let's say to some version of Clang. Oh no, it's still fine, it still says 0. So what I'm trying to tell you is that this program here returns 0. This is just an accident. It's random because width here at this point is uninitialized. So you're looking at undefined behavior. And now, first step, I want to prove that I'm telling you the truth. And second, I want to provide you better options writing this code and safeguarding it. So the best way for me to prove that I'm right here is using C++ 20's consteval functionality. I could also put it in a static assert, but that one is way easier. Now we can see the compiler here tells us, oh, this code is not valid because the variable widget is a non-literal type. So first step is, of course, let's make that thing constexpr. Next thing now is, the call to check fails. And this is what I'm really looking for, because it tells me the read of an uninitialized object is not allowed in a constant expression. And the compiler tells me specifically here that width is an uninitialized object. Plenty of ways to make this code compile, so make things right. The option we had all the time, more or less, would be saying we default initialize the width here in the constructor's initializer list. The other option would be saying we are using default member initializing at the top of the class here for our data member width. Things start working. I have an issue with all these built-in types because of that problem. They might be initialized. Let's go a step back, say we don't use default member initialization. You should, but for this purpose of this exercise, let's say you don't. We say, let's make it equal default because this is what we can have in C++ 20, right? Now we can see the code, of course, still doesn't compile. The question is, why did I say of course? Because we didn't make it right. And there is something that you can do to ensure that even if you forgot to initialize this thing, that things still work out in your favor. Step number 1 is make your default constructor use equal default if you don't do anything else. And then use uniform initialization to create your object. You now can see it starts compiling and it starts working, because in this combination, uniform initialization together with equal default the compiler ensures that width gets default initialized. So this is the power of these two features together combined. If I opt for an empty constructor body, the compiler doesn't apply its magic, because this is our constructor. Compiler doesn't know what to do. But together with equal default, the compiler knows it's its own constructor. We say with empty curly braces that we want this thing default initialized, so the compiler default initializes all your data members, so even the ones you forgot. Let me be very clear. In my opinion, perfect code would be you use default member initialization together with equals default, together with uniform initialization. I just want to show you that even if you forget this piece here, the rest guards you, okay? So if you want to write good code by default, you should of course use default member initialization here. Use equals default for your constructors, copy constructors, for all the special member functions you don't really want to touch, but you have to do something. So technically this is undefined behavior here. If I say equal default, I shouldn't mark it constexpr. Then use uniform initialization when you initialize your objects. Because if you don't forget one of the steps, the two others that you made might help you still writing well-defined, undefined behavior-free code. So I hope this helps you and enables you to write code with less undefined behavior in the future, and thumbs up for having undefined behavior free code, of course. That's it for today. Thanks for watching.